Awesome. Hi, good day everyone. I'm Paul Theriault, as he said, from Mozilla, and here to talk to you about Let's Encrypt. So that's pretty much my talk in a nutshell. So
awesome.
I'll
got your halves on the speakers for you.
Yeah, awesome.
Yeah,
right?
sweet.
I'm also basically a Let's Encrypt user. I haven't worked directly on the Let's Encrypt project, but someone who does asked me to come and make some noise about it and get people involved in Let's Encrypt. So I'm here just to give you a little bit of an overview, dive into a little bit about the technical details, not too much, but also let you know how you can get involved and how you might use it in your own organizations or also contribute to the effort. Just a quick show of hands, who's actually heard of Let's Encrypt? Okay, awesome. And used Let's Encrypt? A few people? Okay, perfect. That's exactly like what we're going for. So hopefully by the end of today I'll convince you all that it's really great and you should get involved. Now, if I figure out how to use the clicker. Am I doing something wrong? Do I press right?
Maybe.
Oh, okay, I did something.
The slides are also down here.
Awesome. Okay, fantastic. Great. So I'm a security guy. I work on web security mainly. But just to summarize what I'm talking about when I'm talking about security today, we're talking about sort of 4 different things. We're talking about confidentiality. So in the browser context, it's not people not being able to spy on what you're going to visit. We're talking about privacy. So has anyone heard of, like, maybe in the recent years, things like tracking cookies or super cookies that there's been lots of different incidences. Sometimes it's ISPs or other people on your network path injecting in like tracking cookies and like modifying the page for like advertising purposes. So SSL provides you a protection against that. There's also like protecting the integrity of the content that you want to see on the web. Injected advertising, such as like when you're on public Wi-Fi, sometimes you'll see that your ads will get replaced and things like that on HTTP sites. And then the last part of security, another part of security is about authenticity. So making sure like who you're talking to. So when we say security is important, these are the things that we mean. And for security to be effective, it needs to be everywhere. Everyone here uses secure connections to all of their network devices, right? There's no more telnet anymore.
Oh, correct.
Yeah. Well, what about other services like LDAP, IRC, messaging systems, email systems, message queue? So I don't need to ask that question. I was a pen tester in my former role before coming here, and like the absence of secure connections kept me well employed. But we're trying to sort of put a stop to that, and we're trying to make it easier to secure your systems. And that's what we're here to talk about. Just so you don't have to take my word for it. So currently, if 58% of all Firefox page views are insecured. 36% of inbound SMTP connections to Gmail are insecure. Hundreds of thousands of routers around the world. Has anyone used Showdown before? If you have a quick squiz on Showdown for finding all sorts of devices that sit on the internet that are sitting there with unencrypted admin interfaces. Hacker's dream, right? Makes it really easy. So what are we going to do about it? Or why is it the way? Like everyone knows. The challenge is like it's not easy to get an SSL certificate. I mean, it's on the scale of things. It's not terribly hard, but it's not as easy as it could be. You usually have to go and you fill out a web form. You then have to pay for it usually. And then you have to prove you own the domain. There's no real standard way to do that, so depending on who you're working with, that might mean getting an email back and then having to copy something out of an email, setting up, doing things manually. It's all in all a bit of a painful experience, especially when you're talking about services that maybe you don't care that much about, like it'd be nice to have it secure, but hey, is it worth the pain? And then in a year's time, like you have to go and then renew the certificate, and if you forget, then it expires, and then if you're lucky, you'll get a proprietary API to your particular CA, and you might be able to do some sort of automated update. But it's different for every CA, right? So what if it wasn't like that? And this is where Let's Encrypt comes in. Let's Encrypt is a certificate authority, but it's also a sort of a broader initiative to try and improve the CA industry. Let's Encrypt is a CA which is free, transparent, and open. So free as in you can get a certificate that doesn't cost you any money. Transparent in that every certificate that you acquire through Let's Encrypt becomes on the public record. It's tracked as part of certificate transparency, so you can feel more secure about certificates that have gone through this process, in the knowledge that if someone has registered a certificate, then it has been published. So this helps initiatives like tracking when someone issues a dodgy certificate. If somehow like an intermediary cert gets compromised and a bad actor is able to issue a bad certificate, certificate transparency helps in that effort towards detecting those sort of malicious certificates. And finally, it's an open CA. You can find the source code for the client. You can find the source code for the actual CA itself. You can find it's all completely open. And if you wanted to, you are encouraged to fork that code and get involved. So yeah, that's in a nutshell. And I'm going to go into a bit more detail about some of the other things. Another thing to mention, and which I think is basically what I'm going to focus on today, because I think it's the coolest part, is that it's an automated CA as well. So while each CA often has their own sort of processes and ways that you get a certificate, Let's Encrypt is built on a standard mechanism or a protocol for acquiring a certificate, both for proving you own a domain and also getting the certificate, to try and make that automated. And that's the really cool part, because it allows you to do some really funky things and just generally makes the whole experience a lot less painful. Okay, so how does it automate certificates? The way you get certificates with Let's Encrypt is to use a HTTP-based API called APNIC. APNIC is a standards proposal at IETF, which is the Automated Certificate Management Environment. Basically, there's two steps to the protocol. It allows you to prove that you own a certain domain, and also that you can issue certificates for a given domain. Proving that you own the domain is actually the more complicated part. So there's a couple different ways you can do that. And if anyone's here has bought a certificate in the past, you're probably familiar with these sorts of steps. With APNIC, basically, you talk to Let's Encrypt and you say, I would like to prove that I own example.com. And then Let's Encrypt says, okay, we'll prove it. And you can do this in a number of ways. You can provision a DNS record, proving that you own the ability to make changes to DNS. Or you can provision a file on your web server to prove that you own the domain or the web server hosted that domain. So the applicant, you basically, when you apply, you say which challenge you're going to do. The CA then verifies that you've done said challenge. And then once you've proven that, then you're allowed to ask Let's Encrypt to sign your certificates. So yeah, and the point here is that it's a standards protocol. Like, this is what Let's Encrypt uses. But the idea here is that eventually it's not just going to be Let's Encrypt that uses this protocol, and potentially all CAs will use this protocol. So here's it just in a bit more detail. So let's say we're using DNS. You talk to Let's Encrypt and you say, hey, I want example.com. And it says, okay, then put this fingerprint in a DNS record. Let's Encrypt then checks that DNS record and then says, hey, I've managed to observe that you've put the record in place. You can now ask me for certificates. So fairly straightforward, but it's not something that was standardized in the past. And so having it standardized now makes it really easy to get a certificate. Once you've proven to Let's Encrypt that you own a domain, you can say, issue me a certificate for this domain. So you send a certificate signing request, which Let's Encrypt then signs and sends back to you. And all of this part, both the previous slide and this one, can be completely automated. And that's the nice part. This is the same for revocation and renewal. Once you've proven that you own the domain, it can all be automated. So let's talk about a few case studies. So how do you actually use this? Okay, so first of all, let's start with the basic use case. You have a web server, you want to just issue a SSL certificate so that your web server is secure. I'm going to show you a little video in a minute. Fortunately, it uses Chrome, but hey, we're all about multi-browser, interoperational sort of things. This is about the web, the good of the web here. But it's a demo showing a web server called Caddy. Caddy is designed to be a very easy-to-use web server. This demo shows Caddy with Let's Encrypt actually bundled inside it. So it makes it so that provisioning is super easy. So hopefully you can see, yeah, it's working. Okay, so here we see someone setting up Caddy. They've typed in their domain name, and then they hit go. Caddy then talks out to Let's Encrypt, does proving of the domain name, and fires up a web server. And it's that easy. And this is the panacea, right? If anyone has ever tried to set up an SSL cert, I'm guessing that wasn't your experience.
Nah.
So as you can see, it works now. It's live, done, magic, right? And that's kind of the end game for the web. But this isn't just benefit. This isn't just a benefit for the web, right? Anything with a fully qualified domain name can benefit from this this technology because it's two separate parts, right? Half of it is you prove that you own the domain, and then you get the certificate, and then what you do with that certificate is kind of up to you. So in terms of increasing automation, DreamHost already built in an APNIC client into their hosting platform so that when they can basically just turn on Let's Encrypt as part of domain provisioning. They automatically include the renewal, so there's no more forgetting to renew certificates and stuff like that. I don't know if that's how popular that is. I gave a talk a few weeks ago to a web community in Melbourne, and a lot of people around the room were a bit dismayed about that because a lot of them actually make money selling certificate renewal services to people and stuff like that. So, well, it'll just make their life easier, right? They'll have less work to do. But yeah, Automatic, the company that runs WordPress.com, used Let's Encrypt to add SSL to all of their hosted WordPress instances. So it's 600,000 sites. Bam. It's not something that would have been feasible in a previous world.
Or affordable.
Or affordable, right? I guess I clicked a link. Someone moving. I hope someone's moving that mouse because otherwise the machine is moving. Okay. Sorry. I'm afraid to click now. Okay. All right. So there's some basic examples, but there's a lot more that you can do with this. And this is an example by an ISP in France called Free. Free are a fairly large ISP in France, 10 million customer clients, for terminating their service to customers. In the past, these boxes have web interfaces, like in your standard router, right? Someone ships you a router. It's always HTTP, right? And why is that? Well, Free face the same problems that everyone always has, right? You can't do TLS on an internal network because the things don't have a fully qualified domain name, right? you could maybe give them a domain name, but then it's too expensive to buy a certificate for every single one of those devices. You could potentially use a wildcard certificate, but then you're shipping the keys for that certificate on every single device. So there's just no way you can do that from a security perspective. And you could use a self-signed certificate, but obviously that's not going to work for customers because they're presented with the big scary red screen of death when they go to their admin interface. But with Let's Encrypt, Free.fr were able to implement SSL on their shipped gateways. So how did they do that? So what they did was to ship a router with a public key, a key pair unique to the device. So every device that came off their factory line ships with a new key pair. When that device is turned on and it connects back to the access for the user chooses a username, and that becomes the domain name for their home router, basically, or their gateway. Their management server then talks out to Let's Encrypt and says, hey, I'd like to prove that I own this particular subdomain of the free box OS domain. They then go through the DNS challenge to prove that they own that domain, and then they issue a certificate for that domain, and then they give that certificate back to the box. And that's all done completely securely. There's no need for the private keys to leave the box, and it doesn't cost them anything, and it's all completely automated. And that way, they end up with their clients now having secure router interfaces for all of their clients, which is, as a security guy, that's just like freaking awesome. I don't know if anyone's seen like the numerous sort of Csrf router hacks that have come out in the past. It's a fairly sort of common web attack where you basically instruct a website to send a packet to your router to like turn off security or do something malicious like that. And they're really common, and they're really hard to fix because people generally just don't update their routers. People are generally not even aware, and this helps protect against that and other sort of attacks. So, how do I get involved, you say? First of all, if you just want to have a play and just try getting a certificate, there's lots of APNIC clients out there. There's the official Let's Encrypt one, relatively heavyweight. So there's lots of alternatives out there. Depending on your flavor, there's probably someone already who has written a client for it. There's everything ranging from plugins to various web servers to then sort of standalone command tools. So depending on how you plan to use Let's Encrypt, there's probably something there already. But if there isn't, there's a community behind this who are actively involved in writing clients. There's a whole plethora of source code you can get involved. So I would encourage you to do that and get involved. And if you can't find what you need, talk to the community and see if someone's working on something, a client that you need. Of course, yeah. Also, just to note that there's Amazon. If you're using Amazon, there's also an automated tool. It's not Let's Encrypt, but hey, it's automated. So that's great, right? Oh, I did it again. Sorry. Thank you. How do I change? Wrong way. Okay. So what's the effect of Let's Encrypt? So Let's Encrypt went into open beta at the start of November. This slide is actually out of date. There's a really great blog post on the weekend. I've got a few more slides from that. But basically, there's now about 2.5 million domains that now have certificates that didn't have certificates in the past. That's, so as it says, 10% growth in the number of domains. This is like one of the greatest pictures I think that you can show. This is on the left, or right, left, shows domains that have a certificate with Let's Encrypt. The right shows domains that previously had a certificate from a different CA. So that gives you an idea of how many domains that didn't have a cert that now have a cert. So that's awesome. Let's Encrypt is now the 4th largest CA in terms of the number of observed certificates, observed unexpired certificates by issuer. Which is also, like, that's amazing, right? Like, that's a couple months. It shows you what sort of demand there was in the market for a, not just free, but automated, like, and making this process easy, right? If you're interested in that, I'd recommend JC Jones is the guy who did this analysis. He's a technical advisor to Let's Encrypt. It's a really interesting blog post, actually. So what can you do? Look around at your infrastructure, find things that don't have a certificate and get them having a certificate, but not just get them having a certificate, get them automated. You can now automatically request a certificate. At the moment, currently, the Let's Encrypt CA has a 3-month expiration on all certificates. Basically, it's a precaution thing in case they mess things up. They want to try and minimize impact. But the nice thing is it's automated, right? So renewal, in theory, should be completely automated. Join the IETF effort towards trying to standardize the APNIC protocol, if that's your thing. Obviously, as a security guy, advocate for all your services to be secured. Encourage the CAs that you work with to implement the APNIC protocol. And this is the whole thing about Let's Encrypt. It's not about, like, getting people to switch to Let's Encrypt. It's about making it an industry standard and pushing the web forward. Also, get involved with the Let's Encrypt community. That's probably the easiest thing you can do and something that's really beneficial. At the moment, with this open beta process, getting involved, trying it out, especially reporting on the things that are more difficult or problems you ran into, operating systems that don't play nicely with this CAs, things like that. Like, that's something that you can really provide value on. And then obviously, if you're into coding and that sort of stuff, fork the code on GitHub, have a play with it, and see what you can do. So yeah, that's all I've got today, and hope you all have fun playing with Let's Encrypt. Cheers.
Awesome. Thank you very much. Do we have any questions? There's plenty of time if anyone's got any Let's Encrypt questions. No? Maybe?
Sure.
What's browser support like compared to the paid one?
So currently, Let's Encrypt is cross-signed with an IdenTrust CA. So it's from years and years and years ago. I think it's Firefox 2. I'm not sure the Chrome version, but years. The one point that I know that is a sticking point at the moment for a number of people is XP support is limited, not because of the CA, but because of something to do with the way the particular CA that does the cross-signing of this Let's Encrypt cert, it doesn't work with XP Service Pack 2, and there's some trickiness on Service Pack 3. So the community's working through that at the moment. So I think, as far as I understand it, it's to do with the particular cross-signing. So I'm not sure what the solution there is in long term, but yeah. Any other questions?
Cool. Ask a question there, because otherwise I've got to run the mic. Can you repeat the question for the stream?
Oh, sure.
Awesome.
Sure.
Cheers.
Could you talk a little bit about the rate limiting that's involved in the Let's Encrypt service? I've seen some larger organizations say we couldn't use this because our requests aren't coordinated enough that we could be sure of getting them through when we need to get them through.
So the question was around the rate limiting on the Let's Encrypt CA service. Unfortunately, I don't know. I don't really have the answer. I know the why of why they're doing it, but I'm not. Yeah, couldn't comment on that. Sorry.
Awesome.
But I'm sure you could find the answer on the community. So I'd direct you there probably. Yeah.
Great stuff. Thanks a lot, Paul.
Cheers.
Okay, awesome. Next up, Geoff Huston with Why DANE. That's all the intro. That's it. Yeah, that's it. Do you want this? Do you want that?
How do you understood that last talk? So you all know about why certificates work, what they're meant to do, and all their strengths and weaknesses. So I can just sit down, right? Because this talk actually backpedals a fair bit, because I think it's sort of useful to sort of understand what's going on and about the whys and wherefores of certificates. They were a hack. They were introduced by Netscape in '95. It was a stopgap measure. They just did it because no one else was doing anything. It was probably a mistake. So, this is my bank. This is my bank. And when I type in the browser, www.combank.com.au, because I'm, a good little Australian, I use an Australian bank, it's sort of easier that way, and the financial laundering folk aren't after me, I get that screen. And when I press the button that says log in, I give them my credentials, and all of a sudden, it's my money, okay? What happened? How did I get to that screen? Because I'm like, it looks like the Commonwealth Bank. Every time I type in combank.com.au, that's the screen that comes up. So, that has to be the bank, right? Think about your own habit. Think for 1 second. How do you know it's your bank? Because it looks the same as it did last time, okay? So I looked, and I really shouldn't have. Because when I looked, I found that what had happened is my machine had asked the DNS for www.combank.com.au. And because it's kind of a V4 kind of world, back came an answer. 104.97.235.12. You can do this too, and you're in New Zealand, you might get a slightly different answer. It's a bit interesting. But let's just press on. So then, because it's my bank, and I want to go there, my browser goes, open up port 443, because it's secure. Okay? 104.97.235.12. So let's ask the DNS, because the DNS knows everything. What is 12.235.97.104.inadra.arpa? In other words, what's the reverse DNS of that IP address? Is it the Commonwealth Bank? Actually, no, I'm with the Bank of Akamai. Because what comes back is Akamai. Now, if you're in Canada, every major bank will give you the same answer. That's not the IP address of the Commonwealth Bank, is it? They didn't get that address. I'm not connecting to a Commonwealth Bank property. I'm connecting to someone else, because the Commonwealth Bank has 140.168.0.0 through to 255. So they've got a /16, and they've also got a few, and I think they've got one whole /24. That's what the Commonwealth Bank has, and I'm not using that. So how do I know I got to the right service? And more to the point, if I was the sort of Homeland Security person in Australia, why is a whole bunch of domestic banking activity being redirected to a company which last I saw was American? Who's running? Who has control of it? Because it isn't the Commonwealth Bank. It is not the Commonwealth Bank. It's someone else. And if I was the Canadians, I would get really, really worried, because every single major bank is south of the border. It's kind of, wow. Have we really managed to make a network that's that astonishingly weird that all of a sudden all your major financial instruments are somewhere else? But okay, let's just follow the fiction here. I think I'm going to the Commonwealth Bank, but in actual fact I'm going to Akamai. So why should I continue to put in my username and password? Why should I give Akamai all my secrets, right? Because that's the question. So I was connecting to port 443, so some magic happened. And this is where this whole issue of certificates comes in. Because once I connect to Akamai, not to the Commonwealth Bank, I say, I'm the client, give me something I can trust. Because I think I'm connecting to the Commonwealth Bank. I've connected to this address, and I'm not going to tell you the name yet. You give me a certificate. Or if I'm running something more recent, I might tell you the name with server name indication. But either way, I'm going to go, explain to me why you're the Commonwealth Bank. And so the server says, here's a certificate that demonstrates I am whom I'm pretending to be. This is the domain name certificate, which in theory, good theory, only the holder of the domain name has the private key. So when it sends me that certificate, what it's really saying is, you might think you're connecting to Akamai, but Akamai have got this certificate so they can mimic me. And then we go and exchange keys, we encrypt the session, we move off, and off we go. It's all finished and the handshake's done, right? So there's a few really, really interesting questions here. I get a certificate. Now, as anyone's used certificates, you can go, Google search certificate manufacturing, and you can get all kinds of software that'll mint certificates in microseconds. It's not hard, because it's just a piece of binary glob, right? So how do I know that the certificate that Akamai gave me, not the Commonwealth Bank, was a certificate that the Akamai only got because the Commonwealth Bank told them? How do I know that I'm at the genuine article? Well, my browser went green. So obviously it's secure. Because otherwise, why would it go green, right? You can program it to go green, but let's not go there. Okay. My browser, you all into online banking yet? You're convinced? My browser goes green. So you go, well, what's the certificate you just gave me that, let me know that you were really the Commonwealth Bank? And it says, this is a certificate. And it's the commonwealthbank.com.au. And my browser, Safari, reckons it's valid. How the hell did it know that? Did it ring up the Commonwealth Bank and go, what's your key? No. There's one other thing going on there. And you'll see a little bit further down, there's an issuer, Symantec. We'll get back to him. So what actually happened was that somewhere deep in the bowels of the Commonwealth Bank, and hopefully deep in the bowels of your bank, some person sat on a terminal and said, key gen. And they generated two binary blobs, right? A private key and a public key. And they took the public key, and in the case of the Commonwealth Bank, they sent a signing request to a company that goes by the name of Symantec. Hopefully it was the real Symantec. We don't know. Now, Symantec only does things in exchange for money. So, money changed hands. And possibly because money changed hands, or if you want to be charitable, possibly because Symantec did some checking. We don't know. But we assume that they checked. We'd like to think so. It's my bank. Yeah, right. Symantec then issue a certificate. And what that certificate says is, we didn't see it happen. We have no knowledge that it really happened. But we're willing to issue a certificate that says that you own the domain name combank.com.au. Okay. They aren't the registrar of com.au. They're not VeriSign. They actually don't know that happened. But they're willing to issue a certificate. Right? So that's what's in the certificate. So as long as that public key comes to me there, that public key is in that certificate, as long as that particular public key comes to me, I know that even though I'm connecting to Akamai, Akamai is validly representing the Commonwealth Bank. Yeah? So, I'm trusting Symantec, because that's really now what it gets to. So the only reason why I think this is my bank is that Symantec are willing to issue a certificate saying, combank.com.au owns this key pair, I've just given you the public key. Why should I trust Symantec? Well, I trust a lot of people, evidently. You can find out how many people you trust, and the answer is typically around 1,500 folk that you've never met. Now, they all share one thing in common: they do things for money. We hope they only do certain things for money, but they do things for money. In exchange for money, they issue certificates, right? So that's the party I'm trusting, amongst all the other folk there, and there are a lot of them. My machine trusts them all, right? Every last one, including this one. Now, this one's interesting. This is CNNIC. Know them, some of their people are here. This is a network information centre run by the Chinese government. This is a certificate authority that in Google's blog, when? God, this is small. March of last year. They issued effectively a registration services agreement. They allowed someone else to mint certificates in their name. Your browser doesn't know this, it just trusts. They allowed someone else to mint certificates in their name. Those certificates just happened to be star.google.com. And the folk that were doing it just happened to be a communications body inside Egypt. And so if you sat on the wire in Egypt with this fake certificate, when some poor bastard said, connect me to mail.google.com, you could get the fake certificate and the screen would go green. And you might not notice it, particularly if you weren't running Chrome. But instead of saying whoever Google use, it would say CNNIC. But it'd still be green. There would be no reason for you to look that up. And so what I'm saying is that even though I trust a lot of folk, some of them don't obey the rules all the time. And they do things for money that they should not be doing. Or maybe it was a favour. Yeah, thanks, guys. Just below there is our dear friends Komodo. I saw Komodo on your list there. Yeah, you did, yeah. Wow. What's the date there? Pretty recent.
April 5th, 2011.
The Komodo hack. You know, CAs want to be helpful. Like Let's Encrypt, they all want to be helpful. They all put their stuff online. Oops. You stand up a server. Let's say it's a Linux server. You use some old stuff. Some person you've never met walks right through it all. Oops. And uses it to mint certificates. Every certificate they mint, we all trust. We all trust. So this all gets really, really, really bad really, really quickly. Here's the front page, Herald Tribune. It was from a few years back. This was the result of the Komodo hack. Users in Iran basically had their email tapped by the Iranian authorities using a fake certificate minted through Komodo and DigiNotar. Could have been you. Could have been me. Could have been any of us. This is where the system is good. Now, you know, DigiNotar, wonderful web page, lots of colours, but what that says in Dutch is that they went bankrupt. The Dutch tax authorities were using it for their online tax return. Oops. It seemed like a good idea at the time. They were probably cheap. So, what's the problem? The problem is in the very, very architecture of this certificate system that was a hack in '95. Because what's going on is that while I get a certificate, I don't know whom should have issued it. So if any one of those 1,500 trusted CAs, if any one of them goes rogue, I'll trust all of their products just as well. Any CA can validate a certificate in this model. So, you know, Isn't it? It's just awesome. Think about that in the real world. I put that lock on my front door. I feel really good about it, right? You can come along with any key. Pick one out of your pocket. Who gives a shit? And it'll unlock the door. Great lock, eh? Anybody can unlock this shit. This is what you're trusting. This is behind the CommBank. How do I know that the certificate I got was real? No clue. No clue. How do I know tomorrow's certificate will be real? No clue. My browser will just trust it. It's fine. If it's a man in the middle, and I'm actually getting the real website, and all they're doing is pulling down my username and password, I can't tell. It looks good, feels good, the browser's gone brilliantly green, you know, it's all just wonderful, but it's crap. Any key can open these locks. So, the real problem is, because any key can open these locks, no one's incented to do a good job. Why should I pay you, bad example because you're free, why should I pay you $1,000 when exactly the same sort of utility certificate is available from you for $5? No one's incented to do a good job because this is a race to the bottom, because a good certificate is trusted equally as a bad certificate, if you will. Doesn't matter. A certificate is a certificate. They don't come in grades anymore. So, quite frankly, the entire CA structure is only as strong as the weakest CA. And like I said, you've got about 1,500 of these folk issuing certificates. And if you really want the awesome list, it's quite an old URL, but it really is scary, you know. And if you read Google's security blog for updates of which CA went rogue which week, you can get even more depressed. And you'll stop doing online banking, I assure you. So there's something wrong about what we're doing. And I suppose the real issue is that these CAs are competitive. That certificate is the same as that, is the same as that, is the same as that. So does this mean that I'll get better market share by doing more work, by making it more secure, more resilient? Is quality rewarded in a commercial marketplace? Of course not. Cheapest wins. So this is a market that basically rewards the crappiest player, because that's the one that steals market share, because certificates are all the same. So options, love options. You just heard option A. Just take all the money out of the system. It doesn't address the core of the problem, or maybe it does, but it's certainly interesting that now I've got a player who just simply says, if you can control the web asset, you've got a certificate. All the web asset. How many websites get hacked every day? To a round number. A few. It was never meant to be that rock solid. It's a cheap system, it works, it's brilliant, you get what you pay for. But the problem is, this kind of automated system isn't really the answer in the long run. Because once we start automating this process, we still haven't actually fixed the basic problem that it's a third-party commentary about the DNS. Because this is an attestation that you have that domain name, but the person making that attestation is not the owner, so the person who actually owns and controls that domain. It's not the domain name admin. It's not the person who's got the credit card account of that domain name. No, 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 no. So this system is always going to be interesting. How good is Let's Encrypt? Will it improve? We're going to find out this year, because they're minting them like crazy. So whatever the result's going to be, and I'm not going to judge it, we're going to find out. And we're going to find out really, really fast. Because the bad guys know this as much as the good. This is not just, if you're a good guy, click here. Just click here, right? Just do this. Experiment. Everyone's doing it. Google, of course, have decided that the answer is insanity. That browsers have infinite memory and upgrades can happen all the time, and so we're just going to list everything in pinning. So this certificate is going to be pinned against this CA, which works fine if you pin google.com and you just Google. How many domain names are there? To the closest billion? It's not a scalable system. It works for Google, good on Google. Doesn't work for me, Joe user. Oops. So, you know, it's a solution when you make security a luxury good. Should security be a luxury good? Is this our internet or their internet? Should I be able to have a secure site as Geoff, or do I have to pay Google? Whose network is it? So I would contend that making security a luxury is not in anyone's interest in the long run. This is our network, not their network. So I'm sorry, but personal opinion says that's insane. It doesn't scale to everyone. It's a marginal solution for some marginal players. Great, they happen to be Google. It's a big margin, but Google is not the internet and it's not everyone. Yes, I know, Warren, you'll have your say. This is opinion time. So this is really opinion time, and this is obviously opinion time. Option C. You know, for Christ's sake, this is the absolute answer. No matter what the question in the idea, someone always says that at some point. You know, the DNS is the answer. Routing security, you name it, the answer is the DNS. And bizarrely, sometimes they're right. They're absolutely dead set right. Just whack it in the DNS. So, you know, how do I know you have that domain name? Well, ask the DNS. The DNS will tell you if you have that domain name. So where do I find the public key? Why don't I just look it up in the DNS? And, you know, why not just query the DNS for this pinning record? Who is the CA for combank.com.au? Question mark, Mr. DNS. Symantec. That's a fine way of doing things. Just ask the DNS. I can go one further. You know, tell me the issue with CA's public key. Tell me which one I should trust. Don't just tell me Symantec, give me the key value. DNS can tell you. Hell, just give me the hash of the domain name cert. Are you actually giving me the real cert? DNS, is that cert for real? Well, stuff CAs, give me the certificate. Mint your own, I don't care, but if the DNS tells me that's the public key of that domain name, I've no reason to disbelieve it. Sort of. So you sort of get to the answer of, if I could trust the DNS, interesting point. If I could trust the DNS, I don't need a CA. So how do I trust the DNS? Well, we'll get there, because you can, if you do the right thing. So DANE, go and read some RFCs, it's really, really easy. There's this certain record called a TLSA resource record. And you can use it in a whole bunch of ways depending on what kind of flavour you like. Maybe the Commonwealth Bank would like to say, only trust the certificate issued by Symantec. Here's the hash of that CA. Trust Symantec and no one else. It's like super pinning, and it's pinning inside the DNS. So that's really cool. The Egyptians and CNNIC cannot delude me. They just can't. And that's a good thing, because now my CA, or at least the Commonwealth Bank CA, has to be compromised to mislead me as a customer. Only one CA can be a bad CA at that point. I could go a little further. Give me the hash of the certificate Symantec issued, so I can then match the two certificates. So give me that end entity certificate hash. If it's not that certificate, don't trust it. Something bad is going on. Or I could even go one further, stuff CAs. If you trust the DNS absolutely, why not? So options in DANE, it doesn't tell you which to use. You can use whichever one you want. But it does give you a second way of figuring out if the certificate you're being presented is the real deal. So what happens now? In vanilla DANE, and there are obvious variants because we're trying to make it better, I get this certificate and immediately I go sideways into the DNS and go, can I trust this certificate? So I ask for the TLSA resource record of the name I was going to. Hi, combank.com.au. I've already asked for an A record. Now give me your TLSA record, your TLSA resource record, because I need to check this certificate. If I can do a match, cool. If I can't, not cool. Not even a dialogue. Do not go there. This is shit. This certificate is really not valid. Do you want to go there? Crap, don't go there. It's not the real deal. So then you can do a key exchange because you know what you're talking with. So there's the kind of slight modification that when you get back that certificate, you take the DNS name you originally used, and at the time you get the server hello, you do a sideways lookup in the DNS a second time or TLSA query. Just one problem. There's a lot of folk making a lot of money about lying in the DNS, right? It's under constant attack, because when you just put everything in the DNS, then I can fool you by putting crap in the DNS, because, you know, that's my job, right? That's your job, that's our job, you know. So, how do I trust the DNS? Unless I can fix the DNS, this is one step forward, one step back, isn't it? Because I ask for a TLSA record, and Mr. Evil Man in the middle goes, ho, 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 here's a fake TLSA record as well, I'm no better off. So I need to fix the DNS. Fortunately, we have a way of doing this. I mean, the good old IETF were working on this one. I think it was about a 15-year effort. It took about 10 versions and many people and much blood on the floor. But we actually do have a remarkably good framework for securing the DNS. You know, it's called Dns Sec. And Dns Sec is actually really, really brilliant. It's brilliant because I think it actually got to the essence of cryptography without dragging along the crap of certificates. It dispensed with them. It said the real issue is actually about trust in hierarchies. So we all start in a hierarchical name system, the root. And what actually happens is the root has a key. And every single entity in that root zone is signed with that key. And when you ask for something, and 70% of all DNS queries ask for the signature. So there's the same thing. There's signing going on inside example.com. So when you get back www.example.com, this is how you got it. And you can actually do a walk back to go, do I trust the signature on that record? And if you trust the root key, everything else can be computed. As long as you trust the root key, everything else can be computed. Now, what's that telling you? Telling you two things which are really, really valuable. It's the real deal, and it can't be repudiated. That answer truly was the answer for www.example.com, and they can't deny it either, because it's signed and the signature is current and valid. That's really powerful. So as long as you have a local trust anchor, you can do an awful lot with putting things in Dns Sec, the signed DNS, by constructing this backwards path. Put the two together and you start to get a really interesting framework for security that works a whole lot better. Because now I go to combank.com.au and I might well get a certificate being presented by the server, but I then do a Dns Sec look at combank.com.au asking for the TLSA record, and I validate that answer. And because I can validate that answer, I can trust that that was put in the zone of combank.com.au by the folk who have that key. They put it in, nobody else, no man in the middle, nothing, and that was the value they put in, no one else changed it. At that point, I know it's my bank. The problem is, they don't do it. Oops. So all of that, so close, but no, so far. So we need both. There's not a lot of DANE out there, and there are a whole bunch of reasons, and we can get into that. That's a real shame. I wish Chrome would get their act into gear, because Chrome is 68% of the browser market these days, and it would be so good if it wasn't just a bolt-on, it was really just part of the fabric. But, you know, we will try. But on the other side, how many folk validate DNS these days? That's around 15% of the world is validating Dns Sec. If you're generous, you'll find 5% of the world doing V6. V6 would kill for these numbers. There's an extraordinary number of folk actually doing Dns Sec validation right now today. And this is the real deal. This is the stuff that goes, if I invalidly sign, you won't go there. There's actually double that number doing Dns Sec, but as soon as you go invalid signature, they go, I have this other result. Here's that one, because I desperately want to give you an answer. Even if you remove that loony fringe, you know, there's around 16% of the internet that says bad sign, no answer. That's a serve fail. Get the real deal or get nothing. That's a big number. That's really, really cool. So there are other ways of doing this too, because the big thing I hear about this is that if I go back, see that lookup of the TLSA? That could possibly take fractions of a millisecond. You know, it could take time. And in the browser world, if Firefox is 10 milliseconds slower than Chrome, oh my God, everyone gets to hear, let's fix this up. And they certainly talk about, you know, the multi-million-dollar millisecond. So can you avoid that additional DNS overhead sitting inside the application? I really like this. I saw it on the mailing list of DANE, and I'm not sure what happened to it, but quite frankly, I just loved it. This is just so clever. You have the root key of the DNS, because you're doing DNS Sec validation, and you should have a root key. It's a good thing, get it, maintain it, you know, love it. When I present you with a certificate in the TLS client bundle, the server presents it, I actually send you all of the DNS Sec answers that you're going to ask for. Yeah, but you might dupe me. And I go, no. It's your root key. If your validates all these answers I've just given you, trust the bugger, because it's good. So I don't even need to look up the DNS. I can just send you the material straight off in the initial handshake. Look at DNS. I think that's really cool. You know, I'll give that top marks for hacking. I like that. So where now? The browser vendors just annoy me. You know, here's this fantastically good idea that could dramatically improve the fact that it really is my bank and your bank and our bank. Could dramatically improve security on the internet. And they go, oh, look, it's going to take a millisecond, get stuffed. But why? No, it's going to take a millisecond, we're not interested. That just absolutely annoys me that these days it's a plug-in for geeks. Why is good security a plug-in for geeks? It should just be there by default. Good security is something we all need. It isn't a luxury good, and it isn't a geek-only tool. You know, fast and insecure is shit. Doesn't help anyone. Even if I take a couple of round trip times, security is worth every last round trip, because it's my money. It might be their bank, but it is really my money, and it's your money too. And, you know, security matters. So, quite frankly, we could all do a much better job. There's a lot of DNS Sec out there, use it. If you're not actually signing your zone, you should be asking, why not? It's really easy. I don't even need a CA to sign a zone. Sign the bloody thing. Publish it. Publish DANE TLSA records. Get a certificate for Let's Encrypt and publish the TLSA. Just whack it in your DNS. It's not hard. Let's Encrypt isn't hard. Making the TLSA is not hard. Then turn on DNS Sec validation in your resolver. That's not hard either. And basically then you can do the plugins that guide using those TLSA records in your key exchange. So it just seems so frustrating that after about 20 odd years we've finally managed to get a solution that gets over that 1995 hack that said, I'm just going to do a quick and dirty hack. Christ, I hope this doesn't take off. We can finally say, right, fine, temporary hack, your time is over. We can do this better. And this, to my mind, is the way of doing it better. Thank you.
Awesome. I'm just going to bring the mic straight to Warren. You can have half an hour.
Do I have to stand here, or do you just want to talk to everyone?
No, you should stand there so I can fight with you. So Warren Kamari, Google, and chair of the DANE working group. First a comment and then a question. So DANE is actually taking off somewhat in the email world. Postio.de and a bunch of other people are actually putting in TLSA records, and that actually solves a fairly large problem. If I send mail to, you know, Geoff@potteroo.net, I have no idea what mail server it's supposed to go to. With DANE, I can actually sort of trust where I go. And then the question, you said that you really like the DNS Sec stapled certificates idea, taking the entire TLSA chain, slapping it in a certificate. The obvious thing is, please, sir, where is your draft?
I read this as an email thing on, I think, your mailing list, and I applauded the gentleman on my screen silently and said, that's a fine idea, and maybe I should reflect it to him, but it is worthy of a draft, Warren. It just seems like an eminently sensible idea, because the major criticism I have heard, and maybe you want to say it instead of me, about the existing mechanism of doing the DNS referrals in the app. Okay. The thing about DNS Sec validation is that the application itself isn't normally doing the validation. It is asking a resolver. And what comes back is that a bit is set from the resolver to you saying it's all good. There's an awfully long path between that resolver and the application. And setting the bit is sometimes, if you're that paranoid, so you're going to go, fine, I'm going to use the get to the DNS. Which is great, but it loads the application with more work. You know, there's a whole bunch more stuff going on that you're kind of doing just to get the validation of these TLSAs. So the other way of doing this is to go, don't have to do the DNS, here are the answers you're going to ask anyway, you know, figure it out from there, because then all you need is the validator and not the whole craft of get DNS. So it's a good thing to write up, Warren.
Yeah. So I mean, a while ago,
I feel a bit naive in that, and someone else who knows more should write it, is my view. But it is a really, really good idea.
yeah. So I mean, Chrome actually did this for a while. Adam Langley baked in code into Chrome, which did the DNS Sec stapled certificates, and it did it for a while. It was, as far as I know, never written up as a draft because Adam became sad with the IETF. And then nobody seemed to be doing it, and so I think it was removed. But presumably it could be put back, right? It
The
exists
browser that is used by 68% of the internet had it, and then it went away. Christ, it's this good idea that just disappears out the door, isn't it?
Maybe if somebody
Please,
had written
Warren,
it up as a
please,
draft.
Warren, bring it back. Honestly, it'd be so good. Really, really. I'll write it if you help me. If it's that idea we can write up. I think it just is too good to let go. It's the best thing we've had for years in this thought space. Yeah. Anyway.
Awesome. Any other questions? No? All right. Thank you very much.
Thanks.
Awesome. That was all we had for this session, so I'm going to give you 25 minutes of your life back. Don't